Everyone, in this video we're going to walk through the solution to this heat transfer problem. We're looking at some grapes that have been cooled to the temperature of liquid nitrogen, negative 196, and then they're going to be warmed in your mouth to body temperature of 37 degrees Celsius. We're working with 5 grams and assuming that they're 100% water to make this calculation fairly straightforward. So feel free to pause and take your time to solve this on your own before we get into this. I encourage you all to start by drawing a temperature versus heat added plot, which is going to be our typical heating curve. Okay, we're going from negative 196 degrees Celsius to 37 degrees Celsius. And along that path, you want to consider if there are or will be any phase changes, because the phase changes, remember, are calculated differently from warming steps. So the temperature of fusion for water is 0 degrees Celsius, and the temperature for vaporization or boiling is 100 degrees Celsius. So we will cross that melting point. So we're going to warm to the melting point of 0 degrees Celsius, at which point it will melt, which temperature is constant for, and then we'll warm to our final value of 37 degrees Celsius. So we have 3 different segments of this curve that will need to be calculated independently. And the total heat involved here would be Q total equals Q1 plus Q2 plus Q3. Okay, so let's look at each individual step here. Q1 is a warming phase, so we'll be looking at the mass times the heat capacity times delta T. My mass is 5 grams. My heat capacity for ice is 2.09 joules per gram Kelvin. And then my change in temperature, remember, is T final minus T initial. So my final temperature for that step is 0 degrees Celsius minus a negative 196 degrees Celsius. So I have a positive 196 degrees Celsius temperature change. And the change in temperature in degrees Celsius is equal to the change in temperature in Kelvin. So I can easily convert those units, no problem. Okay, this works out to be 2,048 joules. And you'll see in a few minutes why, but it's going to be good and easy for us to right away just calculate this in kilojoules. Okay, so 2.048 kilojoules to warm that ice from negative 196 to 0 degrees Celsius. Then we're going to look at our melting phase. In melting, or any phase change, we're looking at the moles times delta H of whatever transition we're looking at. So the moles of water will be equal to my mass divided by my molecular weight. So this is 0.277 moles of water. 0.277 times my heat of fusion from above is 6.02 kilojoules per mole. And this works out to be, where did it go? 1.672 kilojoules. Okay. At this point, we are ready to calculate step 3. So Q3 is another warming phase. So we'll have the mass times CS times delta T. Here, my mass continues to be 5. We haven't lost any mass. The heat capacity for liquid water from above is 4.18 joules per gram Kelvin, and my change in temperature here is 37 Kelvin. So we went from 0 to 37 degrees. And this works out to be 773 joules, or 0.73773 kilojoules. So we have our numbers for step 1, step 2, and step 3, and we're ready to add them up. Q total is equal to Q1 plus Q2 plus Q3. So 2.048 kilojoules plus 1.672 kilojoules plus 0.773 kilojoules. This all adds up to 4.49 kilojoules.